Hi friends, how are you all? In the previous video, I was already explained the pin diagram of 8051 microcontroller, right? So now in this particular video, let us see the memory organization of 8051 microcontroller. Nothing but how many memories are present, what are their locations, we'll see detailedly here. So now let us see memory organization of 8051 microcontroller. Okay, I will take highlighter. Right. Now let us see here. First, consider this is the data memory. Also call it as a RAM memory. Nothing but here we can perform read and write operations. So it's a data memory performing both read and write. So other memory is called it as a program memory. And nothing but it performs only read operation. Whereas data memory perform both read and write. Okay, this is ROM and this is RAM. So we know already in 8051 microcontroller, even in introduction point also I explained introduction of 8051 in that. So 8051 mainly contains two internal memories. One is called as internal RAM memory of size 128 bytes and internal ROM of size 4 kilobytes. And 8051 may also communicate to external RAM and external ROM of size 64 kilobytes because of 16 address lines. Like that I already mentioned, right? Now coming to first data memory. Now this portion is internal data memory, nothing but internal RAM memory, and this portion is external RAM memory, nothing but external RAM, and this is internal RAM. Similarly, this is program memory. Okay, here also we can select either internal or external. Let us see detailedly. Coming to first RAM memory, it will perform both read and write operations. Right. Let us see here first internal RAM. So internal RAM size is actually 00 to 7FH only. Up to this only is internal RAM area. Okay, so in this 00 to 7F, total 128 bytes are present. Okay, so these 128 bytes is ready to perform direct and indirect addressing mode. Whereas next 128 means 80 to FF. So after 7F, next 80 to FF. In that also we have 128 bytes, and those 128 bytes for indirect addressing only. So whereas 00 to 7F 128 bytes suitable for both direct and indirect addressing mode of operation, whereas the next 128 bytes related to only indirect addressing mode. Okay, that's why they mentioned dotted line. So preferably for writing any of the program for a selection of RAM memory, we are using in that range only 00 to 7F, nothing but up to first 128 bytes only related to internal RAM area we are considering. Okay, now like that we have 00 to 7F for internal RAM performing both direct and indirect addressing, and 80 to FF performing only indirect addressing mode of operation. Okay, this is related to RAM. And here remember, for accessing any of the memory, generally we are using only one register, call it as accumulator register. So accumulator register only accessing data from any of the memory. It may be either internal RAM, similarly internal ROM, similarly external RAM and external ROM. Accessing of data is possible from the memories. Preferably we are using only accumulator register. So coming to external RAM. So you know in external RAM means it performs both the read and write operation. That's why read bar and write bar are ready to activate here. And external RAM size is 64 kilobytes. Nothing but 2 power 16. Nothing but 16 address lines are present. Nothing but 16 zeros is the starting address and 16 ones is the ending address. For that, let us say 16 zeros, what is equivalent to hexa 4 zeros H, and 16 ones, what is equivalent to hexa 4FH, 4FH, nothing but FFFF. FFFH is the ending address of this particular external RAM. And because of this external RAM, we can access data, or we can send data to external RAM easily with the help of accumulator register. Okay, there are some separate instructions are there for accessing data from external RAM or sending data to external RAM. Generally, the preferable instruction is move x a at the rate of dptr, or move x at the rate of dptr comma a. Okay, like that one is used for accessing the data from the external RAM, and other is used to send the data to external RAM. So in the addressing modes as well as in the instruction set point of view, I will give you briefly what are the various types of instructions that are used for accessing data from various memories. We'll see detailedly. Now coming to other one is program memory, nothing but ROM memory. Program memory, also call it as a ROM memory. It performs only read operation. Okay, read operations only. Here also we have internal ROM of size 4 kilobytes and external ROM also 8051 can support of size 64 kilobytes. First, whether we are selecting internal ROM or external ROM is decided by one pin, call it as a EA bar. EA bar is called it as a external access bar. External access bar. Generally, this EA bar is preferably used for accessing external memory. For example, if whenever EA bar is equal to 0, then we are activating external access. Then the selected ROM memory is external memory. Whenever EA bar is equal to 1, nothing but external access is disabled. In that case, our selected ROM memory is internal ROM memory. If it is internal ROM memory, generally the size of internal ROM is 40H to 3FH, because of 4 kilobytes of internal ROM. 4 kilobytes means 2 power 12 bytes. Nothing but 2 square into 2 power 10. Nothing but 12 address lines are present. So 12 zeros is the starting address and 12 ones is the ending address. For that, the internal ROM size is 30H to 3FH. 3FH. Okay, for accessing data from internal ROM, there is a one separate instruction is present. That is called as a move C A, @ A plus DPTR. Okay, this is the one instruction. So in the instruction set, I will explain detailedly. Okay, so there will be one suitable instruction is there for accessing data from the internal ROM memory. Here also accumulator register is used to access the data from the internal ROM. The internal ROM size is 4 kilobytes and starting address is 30H and ending address is 3FH. So in order to select internal ROM, EA bar should be 1. For accessing external ROM, EA bar should be 0. Then only we can select external ROM. And in addition to EA bar 0, PSEN bar should be enabled. PSEN bar is program store enable bar pin. Whenever this bar is activating, then only we can select external ROM for accessing because it's a program store enable bar. So it's a program memory. In order to select program memory, this pin must be enabled along with the EA bar pin. Then only we are selecting external ROM memory. Similarly, for selecting internal ROM also, program store enable pin must be enabled. Program store enable bar pin must be enabled. Means by giving 0, then only we can select the ROM memory, either internal or external. So depending on the EA bar, we can select either EA bar. If it is 0, we are selecting external ROM. EA bar equal to 1, then we are selecting internal. So if it is external memory selection, then the starting range, because of size of external ROM is 64 kilobytes. So the size of external ROM is 64 kilobytes. Then what is the starting address? 40H and what is the ending address? 4FH. Okay, like that we have program memory is present and it performs only read operation. Data memory perform both read and write, and data memory having two parts, internal RAM and external RAM. Program memory also two types, internal and external. Selection of internal or external is possible with the help of EA bar pin, and for selecting ROM memory, PSEN bar must be enabled. Let us see internal RAM further. This is on-chip memory, especially internal RAM memory. So I already mentioned internal RAM having 128 bytes only, nothing but here 00 to 7F. 00 to 7F put together having 128 bytes. By 128 bytes means 00 to 7F means it is 2 power 7. 2 power 7. So 2 power 7 means 7 zeros is the starting address, nothing but 00. 7 ones is the ending address. 7 ones means, okay, left side we have 3 ones, right side 4 ones. Right side 4 ones is equal to F. Left side 3 ones equal to 7. Then what is the equivalent XOR 7F? So starting address is 00H and ending address is 7F is the 128 bytes of RAM memory. 128 bytes of internal RAM memory. Okay, these 128 bytes of internal RAM is suitable for performing direct and indirect addressing. Okay, these 128 bytes divided into 3 different parts. One is called as a general purpose registers. Okay, so here it contains 12 bytes. 00 to 1F means 12. 00 to 1F it contains 32. 00 to 1F contains 32 general purpose registers are there, divided in the form of 4 banks: bank 0, bank 1, bank 2 and bank 3. Okay, so in the register organization I will explain briefly. Even bit addressable are the other set of bytes 20 to 2F. Okay? And the remaining 30 to 7F address lines related to direct and indirect addressing mode. Like that, internal RAM is further divided into 3 parts: general purpose registers having some set of locations, bit addressable having some other set of locations, and direct and indirect addressing mode having some other locations. The remaining 80 to FF. Okay, so these locations are not internal RAM, actually it is like external RAM. Okay, now sorry, so these locations 80 to FF related upper 128 RAM locations, but preferably 8051 having only 128 bytes. 8051 having 128 bytes of internal RAM. Okay, this is upper 128 RAM and 128 bytes of RAM, mainly for indirect addressing only. Okay, so in these locations, preferably we have some special functional registers are present, but we concentrate only first 128 bytes only. Okay, for our programming part and other things. So in general purpose registers, we have registers, set of registers are present. Whereas in bit addressable part, each bit having individual bit address as well as byte address. Okay, so for general programming of internal RAM selection and other things, we are using this area 30 to 7F for selection of internal RAM for any result sending or taking results into account. So we are using 30 to 7F locations. Like that, internal RAM is divided in the form of 128 bytes into 3 parts. Okay, whereas internal ROM fixed of 4 kilobytes. Internal ROM is fixed of 4 kilobytes. External ROM is 64 kilobytes of size. Similarly, external RAM is also 64 kilobytes of size, and internal ROM of size only 128 bytes, 00 to 7F only active. Remaining part is upper RAM is not active actually. That's why we are concentrating these 128 bytes, and these 128 bytes are divided in the form of 3 parts. Okay, in the register organization, we'll see detailedly what are the various registers present in that. Okay, this is about the memory organization of 8051 microcontroller. Overall, so we have 4 different memories are possible. So internal RAM of size 128 bytes, then internal ROM of size 4 kilobytes, then external RAM and external ROM of size 64 kilobytes are present. And internal RAM is divided into 3 parts. 128 bytes are divided in the form of general purpose registers, bit addressable area, and direct and indirect addressing mode area. Like that, they are dividing. And for selecting internal or external, we are using EA bar pin. If it is 1, internal. If it is 0, external. And for selecting ROM memory, nothing but the program memory, program store enable bar pin must be activated. So I hope you understand the memory organization of 8051. Okay. Thank you for watching this video.